Welcome to the video on hot melt extrusion, that is HME polymer selection. So whenever you are going for the hot melt extrusion process for pharmaceuticals for making the drug formulation or drug product by HME, that time polymer selection is the very important and critical aspect of the development. In this video we are going to see what are the properties of polymer to be understood and evaluated for successful HME based formulation. Polymer is the key excipient in the hot melt extrusion based formulations. HME involves the mixing, melting together of the drug and polymer, and then the melted mass is extruded through the orifice. The extrudes are formed, and those extrudes are milled and used to make the formulation. So your extrudes act as the intermediate for formulation. Melting and mixing of the polymer and the drug in the HME takes place, and it is the molecular level dispersion, and it is the molecular level type of mixing. It is solubilizing the API in the polymer, the mold or melt stage or state. So you are melting the polymer, you are melting the drug, mixing the polymer and drug, and then getting the molecular dispersion. That dispersion is called as solid dispersion or amorphous solid dispersion. Method of making the solid dispersion or amorphous solid dispersion is HME. The drug may be crystalline or amorphous. For improving the solubility and bioavailability of the low soluble drugs, HME is used. And in the HME technique or solid dispersion technology, the polymer behaves as a solvent for the drug. It also works as a carrier. It inhibits the precipitation. It inhibits the recrystallization of the drug, and that's why it maintains the solubility and it improves the bioavailability. HME process is applying heat, pressure, and mixing to melt the polymer and forcing it through the orifice. And this technique utilizes the equipment called as hot melt extruder. So hot melt extruder involves the use of heat, use of mixing, and use of pressure to mix and melt the polymer and API together. That instrument or equipment is called as HME. Polymer is the main component of HME product design, and polymer is the key excipient for making the amorphous solid dispersions or ASD. So screening of the suitable polymer is required so that you can get the best outcome from the HME technology. And the desired outcome for the HME technology is improved solubility, improved dissolution rate, and in vivo performance. Achieving the good stability, achieving the specific shelf life, conversion and retention of the crystalline API to amorphous. That means if you are using the crystalline API and converting into amorphous, then it should convert and retain the amorphous form. And also it should avoid the crystallinity or avoid the crystalline conversion. It should avoid the recrystallization and precipitation of the drug. Now see the ideal properties of the polymer. So as we have mentioned that HME involves the use of heat. It involves melting. So thermal stability is very important. That is, thermal stability of the polymer is important, as if it is not stable at the high temperature of HME, it may get degraded. So it is required to be stable and should not undergo degradation or decomposition to avoid the impurity formation. Also, polymer degradation or decomposition may lead to loss of HME activity of the polymer or solubilizing activity of the polymer. Then thermoplastic behavior. So the polymer should get soft on heating, and it should be required or it should be there for running the equipment. Softening and deformation on heating is required for running the HME equipment. If the polymer is not getting soft on application of the heat, then running the HME process will be very difficult. Glass transition temperature. So generally the polymer should have the range of TG, let's say for example 50 degree to 180 degree, and most of the HME equipments are run at around 100 to 140 degrees Celsius. So the TG should be in the range of 50 to 180 degree, and this TG is required to run the HME process smoothly. Then hygroscopicity. The ideal property is low hygroscopic nature. High temperature removes the moisture from the polymer, and if the polymer becomes more aggressive towards moisture to gain the moisture, then it is very difficult to handle the product in the manufacturing facility. The prepared extrude and powder may also absorb moisture, and it may be challenging in the process and storage. Also, the polymer should have good flow so that the feeding of the polymer and the drug mixture will be uniform. Then melt viscosity. So as we are providing the temperature to the polymer and API mixture and it is melting, so after melting the viscosity of the polymer should not be much higher. So low melt viscosity is desired to run the process smoothly and to get the good output by good flowability. High melt viscosity will give high torque or breakdown of the process run. High viscosity also will increase the residence time of the drug and polymer in the equipment, and because of that the drug will be exposed to the high temperature for longer time. Decrease in the viscosity on application of the shear pseudoplastic nature is good. So if the polymer is having pseudoplastic nature, that is the good property. So pseudoplastic polymer will have good mixing property and good conveying properties. Solubility and compatibility of the drug. As I have mentioned earlier, polymer is like a solvent for the drug. The polymer gets melted, and in that melt polymer the drug is mixed and drug is melted. That's why it gives you the amorphous solid dispersion. So solvent property of the drug is very important. Solvency or solvent capacity is the property of polymer. Polymer should be able to dissolve the drug to enhance the solubility. Drug to polymer ratio is determined by the solubilizing capacity. Compatibility of the drug to the polymer, and it should be miscible. Polymer should not produce the phase separation. Then toxicity, daily intake, quantity or IID limit, regulatory considerations. So the polymer should be non-toxic and it should be safe to be used for the human consumption, and its daily intake should be higher so that low toxicity and high daily intake will give you the flexibility for using the more amount of polymer. It should have the regulatory compliance. Then what is drug polymer ratio or drug polymer level? So it depends on to the API solubility in the polymer and also the polymer's capacity to solubilize the API and form the amorphous dispersion. Also polymer level is selected based on to the conversion of crystalline API to amorphous API. High polymer required means the drug is less soluble in the polymer. For example, if you want to make extrude of 100 mg drug, if you require 400 mg polymer, that means the ratio is 1:4. Conversion and retention of API amorphous form is critical, and based on that API polymer ratio is selected. Solubilization and inhibition of the precipitation or crystallization is also considered whenever you are going to select the polymer level. So common polymers are there used in the HME, that may be hydrophilic or hydrophobic. So HPMC is there, HPMC acetate succinate is there, polyvinyl pyrrolidone, that is PVP, copovidone, that is called as PVP-PA copolymer. Soluplus polymer is there, which is recently researched for HME. Polyethylene glycol is also there. Hydrazine polymers are there, and methyl cellulose, ethyl cellulose, HPC is also there, hydroxypropyl cellulose. So these are the commonly used polymers. Drugs like posaconazole, venetoclax, ritonavir, itraconazole, and many more are formulated by using the hot melt extrusion technology. And these APIs are converted into amorphous form. Their solid dispersion is prepared, and that's why they are formulated into the formulation by HME technology. So this is the information regarding polymers for HME, how to select the polymer, what are the criteria, what are the ideal properties of polymer to be used in the HME technology. Whenever you are working on the generic formulation, you should try to use the same polymer as used by the reference product. Or if you are going to work onto the novel type of formulation, and if you have to select the polymers, then the basic ideal properties should be considered for polymer selection, that is Kg, melt viscosity, and many more, as I have given in the video. I have also made a video on HME technology for pharmaceuticals, that is the basic information about the HME. So go and watch that video so that you will get good information for the HME technology. I hope this video is informative and you might have got good idea about the polymer selection. Thank you for watching the video.